Interfaces in Unreal. It's going to be a quick high-level overview. So there's three types of interfaces you can have in Unreal. There's the interfaces that are inherited in code. There's the interfaces that could be inherited from in code or Blueprint. And then there's the Blueprint-only interfaces, which only exist in the editor with a U asset. So I'm going to go through this fast and then get into some live coding. If any of this doesn't quite stick, don't worry, you can come back and watch this after the live coding session and it'll make a lot more sense. And so interfaces have two types. So interfaces have two types, the UType and the IType. And the first thing you do is you define a class that inherits from the UInterface type. So this is the UType. And the next thing you define is a IType, which has no inheritance. And the UType is sort of like a reflection type. So you specify things like it's a blueprint type or it's blueprintable, so Blueprint can inherit from this interface. The IType is where the actual interface stuff goes, so the functions. So why interfaces? Interfaces make code more generic. For example, we could make a use system that can operate on usable interfaces. So we're kind of extracting the idea of using something. So the system doesn't need to know if a usable object is a door or like a light switch. The door can implement its usability in its own way, where if it gets used, then it pivots a mesh in 3D. Or the light switch can implement usability in its own way, where it enables or disables a point light based on whether or not it's used in the current state. And so there's Blueprintable and NotBlueprintable interfaces. Blueprintable can be inherited in code or Blueprint, and NotBlueprintable can only be inherited from in code. So here we have a Blueprintable interface, so make our UType from UInterface, make our IType, and since this one is Blueprintable, we can make these BlueprintImplementable events. And we can also make BlueprintNativeEvents, and we can define our default function here. But what we cannot do is define a BlueprintCallable function. Here's the compile error you get if you try to do that, and we'll get a little bit more into that in a moment. It has to do with, I believe, complexity around the IType. But if we look at the not Blueprintable one, so again, you make a UInterface, and this can only be inherited from in code. We make an IType, and this one can actually have BlueprintCallable functions. But what it cannot have is BlueprintImplementable events and BlueprintNativeEvents. If you try to do that, you'll get this compile error here. What it can do, though, is have a virtual function that is completely in code. And this has to do with around the complexity of effectively Blueprintable interfaces not having an IType if a Blueprint implements are run, but we'll get into that in a moment. And so let's consider these situations. We have the code-only ones, so the not Blueprintables. We have the either-or case, so the Blueprintable ones, code or Blueprint. And we have the Blueprint-only. So the first thing we do is we make our UType, then we have our IType. We'll also have a code actor type, and we'll have a Blueprint actor that is going to inherit from our code. The actor in the editor inherits from the actor we define in code. Now, this one inherits from the IType. So we think of the actor as inheriting from the IType of the two interface types. When it comes to the Blueprint side of things, we still have a UType and an IType. And now we have a Blueprint actor, but there's no code actor in between. So which does this inherit from? Well, I think of it as inheriting from the UType, the reflected type. It's not like it inherits from the IType like the code actor did. If we look back, code actor is going up to the IType. And this is sort of a mental model. It may not necessarily be entirely true. When you set something in Blueprint, it's not running a C++ compiler. It is running a Blueprint compiler, but it's not running a C++ compiler. So the way I think about this is we're not actually ever compiling any of this into C++. But this does still define what functions are available. And so if we were to do this entirely in Blueprint, we have the Blueprint interface, which you make an asset, and you add functions to it here, and then we set it in the implemented interfaces of a Blueprint actor. And so I think of that inheritance as just the actor inheriting from the asset. And so to review that, we have a Blueprint actor that might inherit from a code actor, which inherits from the I interface. And we have a Blueprint-only actor, which directly inherits from the U interface. And then for the Blueprint-only side of it, it's a Blueprint actor inheriting from a Blueprint asset. So that's how the inheritance works between the three. And this is also how it works for code-only. For code-only interfaces, it only does that part. And so why do we have this distinction here where it's like, okay, this inherits from I, but we don't think about the Blueprint one inheriting from the I. We think about it inheriting from the U interface, the reflected type. This mental model is useful because it explains some behaviors you'll see in other parts of the engine. You may be used to casting an actor to an actor type and then calling a function based off that actor type. And you can do the same thing with interfaces. You can cast an actor to an interface and it'll return null if it's not an interface, or it'll return not null if it's implementing the interface, and you can call a function. However, this is only true for things implementing the I interface, so the code actors. It's not true for a Blueprint implementing a Blueprintable interface. This will return no pointer. And so to handle that, you need something that works for both cases. And notice in this case here, we are casting to the I type, not the U type. The thing that works in both cases, we are actually using the U type here, And there's a function called implements, and you pass in the type here. And this will return true if it implements this interface. If it does implement it, this is like a type check at runtime, we can use this special generated function for the interface type. And notice this is the IType. And it says execute underscore, and then it's the function name we defined in the interface, the U function. And so in this way, you can execute it on both the code types and the blueprint types. And so you have these two choices, and sometimes it does make sense for this, code only. Sometimes it makes sense for this, where it's blueprintable. So just to drive that home, in the blueprintable side of it, we have the code implementers and we have the blueprint implementers. And this version works for both of those. And for the code only interfaces, so we can only have this situation, it's okay to cast IInterface. And you do actually have to use this in some cases for code only interfaces, because you may add virtual functions that are not U functions and code only functions. There's a subtlety in regards to passing parameters. So here we have this function that takes in a single float parameter, and this time we want to pass the argument called argument value to it, which is just set to 2. Now we have to remember both of these situations, at least for blueprintable interfaces. So we have the interface on the left, which is code interface on the right, which is blueprint. And to invoke that method that we wrote on the interface on both of those, we actually use the execute function. So the function is the function we wrote, prefixed with execute. And so we have the single float parameter, and we're going to pass in the argument value. And we pass it in here, which, if you notice, is actually the second argument to this execute function. The first argument is the actor that we are operating on, because this is effectively like a static function defined by the interface. So there's no object associated with this function call. And so we have to pass the object that we want to invoke this function on to the execute function. And so how do we communicate about interfaces across the code and blueprint boundary? There's a special type called the TScriptInterface. And notice it takes the IType. Now this will work for blueprints and code interfaces if it's a blueprintable interface, but it does take the IType. There is still some caveats to this. And so let's say, how do we actually make one of these? The first thing we want to do is we want to make sure it actually is of this interface type. And so we can call the function implements. And again, notice this is the UType, not the IType here. And so if this other actor implements the interface, we're going to make a TScript object and we'll send that to the blueprint. And so what you can do is you can directly assign the other actor to the interface. And just so you know that the other actor is just a pointer. And so we directly assign to it, and this gives us some new functions. There is a function called GetObject on this script interface, and it'll return an object pointer of the thing that implemented the interface. And there's another function called GetInterface, which will return an interface pointer to the thing that implemented the interface. Now, here's where some of the behavior that the mental model explains comes into play. If you pass in a code actor, you can get a valid pointer for the object, and you can get a valid pointer for the IInterface. If you pass in a blueprint actor, then you'll get a valid pointer for the object, but you will not get a valid pointer for the interface. This will be null pointer. And that's kind of the behavior of the IInterface not existing in Blueprint. Now you can send this to Blueprint, so I have a function here, send interface to Blueprint, and the way that looks is we have a Blueprintable event, and we're passing in a const TScriptInterface, and notice it's the IType and the interface name. And so this is how you can send something on the code side to Blueprint that's implementing the interface. You wrap it in this TScriptInterface. So we have blueprintable and not blueprintable. Again, not blueprintable has BlueprinTCallable, can have virtual functions because they're always is basically guaranteed to exist this IInterface. For the blueprintable ones, though, this IInterface only exists half the time when it's implemented in code, but not Blueprint. And so that's why you have these Blueprintable events, because we expect that a blueprint is basically going to exist. And you have to use that special implements and execute functions to actually call these. You can actually have a virtual function that is associated with this Blueprint native event, and we can explore how that works. So if you're going to Blueprint, you say, hey, I want to implement my Blueprint interface, you can do that by setting it here, and you have these two functions that are defined in code. And let's say you actually don't override the thing that's supposed to return, the Blueprint native event with a return. What happens? So in code, we have this function that takes in the float, and it's going to just return that float back. This is the default implementation that Blueprint did not override here, because this is great. So if the IInterface doesn't exist, then this should be an issue, right? So how does the engine handle that? So I've debugged it here, and it actually returns a default value. So I'm calling the execute blueprint thing with return, and I'm passing in the argument 2. And the return value should be 2 if it used the default implementation. But again, it's as if this I implementation doesn't exist. It returned 1. It returned a default value. So again, the mental model kind of explains this behavior that you see of there not really existing an IInterface when it comes to Blueprint implementing a Blueprintable event. So imagine this is because it can't actually call the function. This is a member function. It needs an object that is of this type. And when we implement something in Blueprint, we're not running the C++ compiler. It's doing the Blueprint compiler, but that's all using like reflection with C++, it seems. And so what's it do here? It just returns a default value of a float, which is 0, because it can't actually run this function that doesn't exist for that particular type. It's not compiled in. And so if you go into Blueprint and you do override this native event, so we have the interface and we override it, and you try to call the parent function, this is grayed out. And again, this is explained by the mental model of there not being an IInterface for blueprints implementing a Blueprintable interface defined in code. There is this TSubclassOf, and TSubclassOf allows you to basically have a reflected class and do things with it. And say you want to constrain that to an interface, you can use this meta specifier for MustImplement and the interface name. And there's another version of this, the meta MustImplement, and you can specify the module name just in case there's multiple interfaces with the same name in your project, maybe with multiple plugins. You can be more explicit here. So this is like a full MustImplement, and this is like a minimal, only saying the interface name. If you go into the editor, when you try to select the class to specify here, this will constrain the options you have available here to be of that interface. And if you didn't do that, you'd have like all the actors in your project specifiable here, which we don't want. Let's say you are in a different situation where you did have a TSubclassOf, but it may or may not be that interface. So this is some class that might be the interface. We don't know. How do you find this out at runtime in code? Well, what you can do is call this function that is similar to the other one. And you say ImplementsInterface, and then you'll use the like UType, so the UType, and get the static class, so they're like the reflected class. You can ask if this class implements that interface, then do some logic in response to that. Otherwise, do some other logic. And so this is how you can test. But again, if you want to constrain it to only be that, then use the MustImplements thing we saw in the previous slide here. So as far as Blueprint goes, Blueprint can call functions on interfaces as well. So how does that look? There's really two situations that stand out to me. There is the situation where you have a TScriptInterface, like we saw earlier, directly. So you can call the function directly on this object. And you know it is, you know the type here, it is a test blueprint interface. You can call it directly. The other situation is you just have a generic UObject. So here we don't actually know if this implements the interface, but you can still call this native function here. And this is a special version with a little envelope here. So this is like sending a message. And so this is going to call that function if it actually is that interface. Otherwise, it's just going to do nothing. The more you work with interfaces, you might start to realize, like, can I subclass interfaces? As in, can I have like an inheritance hierarchy within interfaces? So in Blueprint, if you try and create an interface, right click in the content browser and go interface, and we create this interface asset. If we go into the class options, you can see that it does inherit from UInterface, the interface type here. And this is grayed out. It doesn't let you change it. So you can't actually do interface inheritance in Blueprint. You can't have a shape interface and then like a smooth shape subclass interface. Just can't do that in Blueprint, as far as I can tell. However, in code, you can do this. So there's some complexity here, and I've made this chart to kind of help with that. We've got the base interface, we've got the child interface, and then we have the thing that's actually implementing the interface. So this could be like shape, and this could be like square shape, or rough shape, or like smooth shape. And then we have the implementer. So you still have to make a UInterface, and we still have to make a IInterface as well. There's nothing changed here, so we have the inherit from UInterface, and then the IInterface is not inheriting from anything. But if we want to make a child interface, we again have to make a UInterface, and we're going to inherit from the parent interface here. And so this is not inheriting from UInterface, it's inheriting from the thing above it. And so there's like a direct inheritance right here. The IInterface now is actually inheriting from the above IInterface. So previously there was no inheritance here, but now there is inheritance, and it's effectively inheriting like this. And so we have this kind of like parallel inheritance situation happening. And so if we create an actor, what does it inherit from in code? And it'll actually inherit from the IInterface like normal. So we kind of have this parallel inheritance happening among the interfaces. Now, I would not use interface inheritance lightly because you can end up in a kind of circular inheritance situation. So let's say we have the parent interface and we have like a left child and a right child, and they're both inheriting from this interface. And then maybe some actor wants to inherit from both of these. So you end up in this diamond inheritance pattern issue. But if you go down this route, you need to look up virtual inheritance and how to handle multiple inheritance in C++. This is not really a great pattern, I don't think, multiple inheritance personally, but it has some uses for like mixins and stuff. As far as UInterfaces go, I think I would avoid this complexity. I don't think it really adds too much in most cases, and in the few cases you do maybe have interface inheritance, maybe this isn't really a situation, but it is something you need to consider if you're creating an architecture that has that type of inheritance. Now that we've had an introduction to interfaces and kind of understand the high level, I'm going to go through and code up the different types of interfaces. I recorded this beforehand, so I'm going to be just talking over the code with it playing at a faster speed, but I'll go through all the pieces and you can see how it's actually implemented. So we need to make a UInterface. So we have the U and the I, and that just inherits from UInterface. And we'll make that a blueprint type and Blueprintable. So this is the variant that allows blueprints to implement this without a code class in between, or a code class can do it. And then also we have the IInterface. So here we just make the IInterface, which has the exact same name, and it inherits from nothing. And so this is actually where the functions will go. So we have a BlueprintImplementable event, and we can have a BlueprintNativeEvent, which has a return type, and we can override the default value of this, or the default implementation, like a normal BlueprintNativeEvent. And we'll just pass the value through, so whatever they give us will return. So next we'll make an actor that's going to implement this interface. So we inherit from actor, but we also inherit from the IInterface. And we'll override the BlueprintNativeEvent and just make it multiply by 2, whatever they pass in. And we'll make an actor that's going to be responsible for overlapping. And in this overlap, we will basically do a bunch of casting and implements checks on our interfaces. And so in the constructor, I just disabled collision by default, and I've just generated a begin play function and an overlap function. So in begin play, I'll set a timer. After some time, I'll just enable collision again, which will trigger our overlap. And so in our overlap, we'll do some interface checks and use interfaces. And so if we overlap another actor, how do we test if it's an interface? Well, the way you do that for Blueprintable ones is using this implements function. This also works for not Blueprintable as well, but this is the proper way to do it. And notice it's the U interface, not the I interface. So it's just sort of like a reflection check, like using reflection. And once we've done that check, then we use the I interface and call the execute functions, which are generated for us, so that we're able to kind of call this for both blueprints and code classes. And so here I'll just pass in 2, so the default value should pass the 2 back, and our code version will multiply by 2, and giving us 4, and for blueprint we'll make that multiply by 3, but we'll get to that in a moment. And so I'm just adding some logging, rearranging code here. And so next we'll try casting to the IType, which works for some interfaces but not others. And so we'll call both of our blueprint events directly here. And so this is actually problematic. We'll hit a check saying this is not great code to do because this is only going to work for the code implementers of the interface, not the blueprint implementers, because effectively there's no IType for the blueprint implementations of interfaces, at least for a mental model, which we'll see other evidence that suggests that mental model is a good model to have of interfaces. So we'll add some logging. Compile that. And now we'll make a blueprint class. And it'll be a child class of the code class that is implementing the interface. And we'll make this look a certain way. We'll add a here, go to material, so we can easily distinguish it. And you can see here that we've implemented the blueprint implementable event, which is defined on the interface in code in Blueprint. And we're able to call the parent function. In this case, there's no event, but you can still call the parent functions here. And we'll just print out when we do that. And we'll implement the native event, which looks like a function because it is a return type. So we're able to call the super here, which in code multiplies by 2. And we can print string here. So now we'll make another blueprint class. And for this one, we'll just parent it off actor. Give it a name, and we'll implement the interface in Blueprint. But first, we'll give it a visual and a material so that we can distinguish it. And then if we go to the class settings and down to the interfaces, we can add our interface, and we'll select the TestBP interface, which is a Blueprintable interface that we defined in code previously. And now on the left-hand side, we have our interface functions that we can override and replace. So we'll do that. We'll call our blueprint event. So we'll print a string. Then we'll override the one with a return type, and we'll multiply by 3 this time to distinguish the behavior. And we'll add some text to remind ourselves which one of these is which. And so this is the one implementing it in Blueprint, and this is the one implementing it in C++, the interface that is. So we can drag those into the level, and now we're going to create a new Blueprint class, which will be our overlapper. So this is what will overlap and do our interface checks for us, so that we can prove to ourselves that our functions are doing what we think they are. Give it a name, and we'll add a visual representation to it, give it a material, and some box collision for our actual overlap. And throw that into the level, change the size of this a bit. So now we'll drop some breakpoints here, and we'll pi. So we hit the constructor, which disabled collision, then we set our timer and begin play. And now the timer's up, and it has called our notify actor begin overlap, so we can do our interface checks. And if we look here, this is the first one that was overlapped is the blueprint implementing interface. So this is the blueprint that implemented our code interface. And we go down to the check where we call implements, and we are using that UType. And we go into the if statement, so this correctly identified that this actor is implementing our interface. And now we can invoke the interface functions with the execute generated function. So it's the function name we typed with prefix with execute underscore and the interface type. And same thing for the one with the return type. So we're passing in 2. So this one should have multiplied it by 3, and it did. So we got 6 back, 2 times 3 is 6. And then we log. And now we're down to our cast check. So we're trying to cast the blueprint type to the version of the interface with I. And like I mentioned previously, the blueprint types do not appear to have an I interface type. So this cast should fail. And it does. We go to the log line in the else statement. And now we hit another notify actor begin overlap, which in this case is our code implementing interface. So this is where we have code, a code class that is inheriting from the interface. And we step down here to the implements check. We are able to test that does it implement the interface, and it does. We know for a fact that it did because we wrote the code. But so we got into the if statement. So not only does it work for blueprints, it works for code. And we're able to invoke our functions with the execute generated function again. So we're just invoking the interface functions this way. And we can see that it should multiply by 2, and it did. It correctly called our code version of this override function, so the native event, and it multiplied by 2 rather than 3. And so we can see all of this is working as intended. The difference in behavior is that we will be able to get a valid I interface pointer for the code class. So we went into this interface, and here I'm attempting to actually call the functions of the interface directly on the interface pointer. And if we do that, we'll actually hit a check. It's warning us that, like, hey, don't actually call the functions this way because this is a blueprintable interface and you're not guaranteed to have like an I pointer, basically is how I interpret this. So don't directly call them, use the execute functions. And so we hit that check, and I'm going to call the other function, and we're going to hit the same check, or effectively the same check. Okay, and then we'll continue a bit. And we can see that we passed in 2, and it just gave us back 0. So it's not behaving as we would expect. So it gave us back 0. It should have multiplied by 2 and gave us 4, but this is not the right way to do it for blueprintable interfaces. This is how you would do it for not blueprintable interfaces. And we'll continue on. So now disable the breakpoints, and I'm going to increase the duration of these prints so that we can see that it's working on the blueprint side, that the functions are actually invoking. And you can see here that it's printing, it's actually invoking our blueprint implementable events and native events and stuff. So it is actually setting our events down to blueprint, which is what we wanted for a blueprintable interface. So I'll continue. Now, since this code is problematic, casting on blueprintable interfaces, I'm going to just disable it. And now there's another thing to understand, and that is TScriptInterface. TScriptInterface is how you interact with interfaces across the code and blueprint boundary. And you actually put the I interface as the template type. And despite it being the I interface, it does work with blueprintable interfaces that are implemented in Blueprint. So don't worry about that. But do know you need to use the IType And the way I think about that is just because that's where all the functions live, the like execute functions and stuff. And so we'll give the variable a name, expose it to the editor, and blueprint scripts. And now we're in the implements check, so we know it actually implements the interface. Let's actually set this script interface variable. And you can do that by just assigning it to the actor. And the actor is just an actor pointer here. And because we've already done the check, we know it's the interface, we're just able to assign it. And the script interface gives us two functions. One is called GetObject, and that gives us a UObject that represents whatever is implementing the interface. And we have another one that is GetInterface, which gives us a pointer to the IInterface. And so for Blueprintable interfaces that are implemented by a code class, so a C++ class implementing the interface, we'll get a valid object here, and we'll get a valid I pointer, or interface pointer. But for blueprints that implement that interface, we'll only get a valid object here, but not a valid I pointer. But we can still use this to pass interfaces around. We just cannot get an I interface pointer in code. So I'll add some logging, rename some variables. And now what we'll do is test that out. So I tripped a breakpoint, and this first one is the blueprint that has implemented the interface. And so we'll assign the MyScript interface to that blueprint actor. And then I'll step through this, and we got a valid object pointer, so this is not null. So we were able to get an object from this TScriptInterface. But if we step over to the interface pointer, it's actually null. So we're not able to get a IInterface pointer for a blueprint that implements code interface that is stored in a TScriptInterface. So now continued, and we are hitting the other overlap, which is our code actor that implements the interface. So I'm going to assign that to the TScriptInterface. And I'll grab the two pointers, and if we check the object pointer, you can see it's a non-null pointer, so that was able to work. We were able to query the object from the TScriptInterface. And if I step over to where we get the IInterface, we also have a valid pointer here because the code actually does have an IInterface implemented. So over here we're able to get a valid pointer because the code class directly inherits from the IInterface, and just following the same pattern in mental model that code classes have IInterface pointers, and blueprint classes do not. So continue, and you can see in the logs here that we have like valid addresses, and one address is 0 or null. That's the blueprint one, and the not blueprint one. Continue. And now what we want to do is be able to send like a pointer to something that implements an interface to blueprint. And so how would you do that? You can actually use these as parameters. So we'll say TScriptInterface, again, provide the IInterface and give the variable a name called interface. And over here, we can just call our function send interface to blueprint and provide that script interface that we created. Now on the blueprint side of that, we can override that function where we have the interface exposed. And since the interface has nothing BlueprintCallable, I need to add that here so I can call it on the blueprint side. And I'll save that, recompile. And then over here, I can actually call that function now. And so you can see that we're able to send an interface to blueprint and then call functions on that interface. And so I'll just format our print here. And now if we step through it, and we can see that we did two overlaps and we called the function twice. And in Blueprint, the message passed away too quickly, so I'll change the time to 10 and the color to yellow. Drop one more time, stepped over that, and stepped over it again. So we just did our two overlaps, and I'm calling the function to send it to Blueprint. And we should see prints here. And so you can see that there's two yellow lines now for script interface. Blueprint was able to successfully receive that interface and call a function on it as it returned 20 and 30. One for the Blueprint one and one for the code one. So now we've done that. What we can explore is TSubclassOf. And so you will often expose this to the editor as a way to like spawn an actor or something. You'll say spawn actor of this type of class. And right now this is kind of vague in that it doesn't tell us anything about an interface. Like, does this actor implement any interfaces or what? We don't know. So you can actually check that at runtime using a function off TSubclass pointer. So I'll get our TSubclass pointer. If it's not null, we'll call ImplementsInterface. And here's the tricky part. We will use the UType of the interface and we'll call static class. So we're getting like the reflected class. And this if statement can tell us like, does this actor implement this interface even before we instantiate it? So if I go here and I just select the blueprint interface, which does implement our interface, and I debug this, we are able to see that it took the if statement that was requesting, like, does it implement the interface? And so it was able to detect the class, like the reflection of the class, does it actually implement that interface? And so if we wanted to, we could go ahead and spawn this thing or decide not to spawn it. So we could do logic like that. And so what we will do here now is slot in the other one, the code one, and make sure that check still works. So now we're testing, does the code class implement the interface? And it did. It was able to get into the if statement there, as expected. Right here, as you can see. And next what we'll do is we'll slot in something that doesn't implement the interface. So the overlapper doesn't implement the interface, it just overlaps things and runs the test. And so we'll slot in that class there, run it again, and we're here at the check, does it implement the interface? And you can see the overlapper doesn't implement the interface, so we never set that up. And so this is showing that it can correctly detect that it does implement it or it doesn't. And so what if you wanted to have a TSubclassOf pointer that actually was constrained to an interface type? So here I'll just say a TSubclassOf a UObject, and we'll say it's an interface only class, and I'll expose it to the editor and to blueprint scripts. But the extra bit is in the meta specifier, you can say MustImplement, and then the name of the interface, but remove any other prefixes. So this is the name of the interface as it would appear to like a designer in the editor. So no U, no I, just the interface name. And there's another version of this, so I'll name this the minimal version, where this is the most straightforward to type. So we gotta paste that. What we can do is the full version, which allows us to specify the module that the interface is in. So this is, my project is just UE tutorials, UE CPP tutorials. We can see that from the U project or the build. And so this is the module name and the interface. And what that allows us to do is if we go to the properties, the top one is unconstrained. This is any actor, basically. It's the full list of whatever's in our project, effectively. And the ones that we put the MustImplement on, we're able to select only actors or objects that are implementing that interface. And so both the minimal one and the full one is able to do this, but the regular one at top isn't. And so that's the advantage of the MustImplement meta specifier, that you can constrain it so that you are only ever going to be at something of a interface type. So we've done blueprintable interfaces, but we haven't done code-only interfaces or not blueprintable interfaces. We'll set one of those up. We'll make an UInterface, and so we have the UInterface and the IInterface as normal. Give them the name. And we'll set this one as not blueprintable. We'll make it a blueprint type, so it can be used by Blueprint. It's just not implementable by a blueprint, so you can't override any functions. So if we go to Blueprint, we're not actually able to blueprint it. It's not a blueprintable interface, so it's not selectable as an interface we can implement in Blueprint. So what we can do that we couldn't do before is we can make BlueprinTcallable functions. So we've made a BlueprinTcallable function. We'll give it a body, make it virtual so that we can override it. And what we can't do actually is do this in the Blueprintable interfaces. So if I went up and I tried to add the BlueprintCallable up here, and if we compile that, we get a compile error. So you're not allowed to have a BlueprintCallable function in a Blueprintable interface. And that's probably because the IInterface, it would have to like invoke the function on the IInterface, which doesn't exist for the Blueprintable interfaces. At least that's my reasoning. So it doesn't make sense when there may or may not be an IInterface. However, for the not Blueprintable interfaces, so I've scrolled down back to the one we're writing now, which can have a BlueprintCallable function, there's always going to be an IInterface because it's only implementable in code. So we can't have things like BlueprintCallable functions. So let's create a class that implements this interface. So we inherit from actor, but then we also inherit from the IInterface. And I'll override the BlueprintCallable function down here. Give it a body, and just call the super and log that, so it proves that we overrode it. Now you might think we can do BlueprinttableEvents or BlueprintNativeEvents. So I can throw some right here and try to compile that. So we have a BlueprintImplementIvent, a BlueprintNativeEvent. And if we run the compiler, we get a compile error saying we cannot have Blueprintable events in a not Blueprintable interface. And if you think about it, back in the mental model, we don't have an IInterface for Blueprintable interfaces that were inherited by a blueprint. This one is saying it's not Blueprintable, so we don't have that issue. That's why we can use BlueprintCallable. But since no blueprint can implement this interface, it doesn't make sense that there would be a BlueprintImplementable event because there's no blueprints to implement that event. And so BlueprintImplementable events are effectively just forbidden from a not Blueprintable interface. At least that is how I've reasoned about this. And thinking about it from that light, it seems to make sense to me that you can't implement it in Blueprint, so why would you have a BlueprintImplementable event? And a BlueprintNativeEvent is very similar to a BlueprintImplementable event, just has a default function. So that's why BlueprintNativeEvent is excluded. And so I'll comment those out. The other thing about a not Blueprintable interface, so there's only code implementing this interface, that is, there is guaranteed to be an IInterface. We can put virtual functions here because there will always be an IInterface, so we can write a regular virtual function that has no ufunction markup. It's just a standard C++ virtual function. And so I'll put it down here, we'll override it, and I'll add a log line to prove that it works. And now, in our overlapper, we can still do the implements check. So if it implements that interface, we could do something. The execute function still makes sense because there's no blueprint implementable events or anything. So just comment that out. But we can also, since we're guaranteed to have an IType, since no blueprint can implement it, we can do a cast to this interface. So we cast to the IType, not the UType. And so I'm casting the other actor to our interface type. And we can directly call the BlueprintCallable function, and we can directly call our native C++ virtual function. So it's just like no U function, just regular virtual function. And that's totally fine for not Blueprintable interfaces because they're code only. I had a typo up here. This implements check should be a U. So the implements check still works. I'll add a log here in a moment to prove that because there's nothing stuck into the if statement. But we'll compile this and test it real quick. So to test this, we'll create a blueprint class of our code class. So this is a subclass of our code actor that implements an interface that's only code available. So let's paste that right there. And we'll create a blueprint subclass of that. And I'll give it some visuals so that we know it's the code only one. And give it a cylinder with a material. Throw that in the overlap and move out the other ones. And now we can test that. So I'll drop a breakpoint here and here. And so now we're stepping. And we are able to use the implements check like we were for Blueprintable interfaces, but I don't have any code in the if statement, so I'll have to add that in a moment. But here we can see that the cast works. So we cast to our code interface, cast succeeds, we're in the if statement. We call our BlueprintCallable function, we call our pure C++ virtual function, and we had no issues whatsoever. We didn't hit a check like we did when we directly called the functions with the BlueprintNativeEvent events previously. And I'll add a log line right there so that we can test the implements function. And I'll drop some breakpoints down there. And then we'll run it. And so now we hit our log line within the implements check, so we know that's working. And we cast our interface, and that works because this is, again, a code-only interface. So it has an IType, an IInterface. And we call our BlueprintCallable, which we hit our breakpoint in our BlueprintCallable. And then we call our virtual function, and we also hit our breakpoint there. And we can see they're present in the logs. So now we will make a interface entirely in Blueprint. So if you search for interface at the top, there is BlueprintInterface under the Blueprint category. Create that, give it a name, and open it up. Here we can define the functions that the interface creates. So we'll do one with no return type and one with a return type. And we'll add parameters to it down here. And returns for one of them. Rename those functions. And I will go to the blueprint and I'll implement it in Blueprint. So we'll go to the class settings and implemented interfaces. We'll search for our Blueprint only interface. So this interface is entirely in Blueprint. Code cannot use this interface. And so now we have functions that we can override. So look over here, we can override the functions we defined in our Blueprint interface. I changed the name slightly, but same deal. And notice in the top right corner, you can tell that this was an interface function by the interface icon. And then here's the one for the return type. So we can override the function, do a print, and we'll just return the not of whatever we pass in. So we're doing some sort of logic. And then on the overlap, since this entirely exists in Blueprint, we can't go in code and be checking implements because there's no types to check. So I'll just override the overlap in Blueprint and then do our interface checks here. And so in Blueprint, you can actually cast the interfaces. So this is like our implements check, but we're going to cast our Blueprint interface. And then now we have a direct reference to our interface. And with a reference to our Blueprint interface, we can actually call the functions directly. So we have the no return one and the one that has a return value. And so this is one of two situations. In this case, you actually have the interface and you can call the functions directly. The other case is you don't know whether or not it's an interface, and so you can pass a message. And the message will invoke the function if it exists, or not if it doesn't. So I'll show that here in a moment. And do a sequence to separate them. And so you can see this function is kind of standalone. It has a little envelope, which means it's like the message version of calling this function. And I'll do the same thing for the return value one. Connect those and connect those up like that. And now we can pi to test it. And so we hit our sequence. We're stepping over the nodes. So they should be calling. If I pause, you can see that we have the red text, which shows that we called 4 functions on that Blueprint interface. And so that's all working. 2 of them were false, 2 of them are true, depending on if it was the direct call of the functions or the message version functions. I believe I changed the parameters between those two. So look, yeah, the message versions, I gave it false as the parameter, and I gave it true as the parameter for when we had a direct reference to the interface. So that's how you do it in Blueprint. And just to prove that this works, we can hook that up and unhook the other one. So this is only sending the messages. We have no direct reference to whether or not it's an interface. We're just saying, hey, call these functions if it is an interface. It's like send this message to this actor, and if it implements the interface, then it'll handle it. And I'll set true as the parameters there. And you can see here that we had our overlap, and the red text shows that it was able to call our functions for us, and it's returning true for both of those. Now if I take that out and put in the code one, which doesn't implement the messages, we can run that, and you can see we have no red text referring to input being true or anything like that. So it didn't call our brand new functions from the Blueprint interface because it didn't implement it. It just called what we were doing previously. And so I hope that helps show the surface area of Blueprintable interfaces, not Blueprintable interfaces, and Blueprint-defined interfaces. Hopefully with this information you can make more informed decisions as to the code you're writing and whether or not you want it to be something in Blueprint and the considerations that need to be involved in that decision, or whether it's appropriate for it to just be a code side interface. So if you have any questions, comments, concerns, or even corrections, please post those in the comments below. And until next time.